All right, in this problem, we're given some information here that the surveyor has determined the intersection angle is 28 degrees, and she's measured the external distance E from the PI to the highway center line for the curve and found that to be 73.6 feet. So, from that information, we're going to find the tangent, radius, and that degree of curve in degrees, minutes, seconds for the highway center line. So we know that the I, also known as the delta, is the 28 degrees, and we know that E is 73.6 feet. So we're going to go ahead and use that relationship between E and the tangent to go ahead and back solve for the tangent. So we know that E is equal to that tangent value times the quantity of the tangent of delta over 4. So now we'll go ahead, knowing E and knowing this delta, we can back solve for this tangent. We'll rewrite that algebraically. So the tangent is going to equal E divided by the quantity of tangent delta over 4. And so that becomes 73.6 feet divided by this tangent of 28 over 4. So my tangent value becomes 599.42 feet. And now we can take that information and solve for our radius. Again, back solve using our formula. For our formula here, tangent equals radius times tangent of delta over 2. So now I know tangent, I know delta, so I'll rewrite this to solve for radius. So radius is going to be tangent divided by tangent of delta over 2. So using the value I got above, 599.42 feet for the tangent, and divide that by the tangent of 28 over 2. And so that radius becomes 2404.14 feet. And then the last thing here is to solve for that degree of curve in degree minutes seconds. So my degree of curve formula is 18,000 over pi r. So this becomes 18,000 divided by pi times this 2404.14. And that is 2.3831 degrees. We'll convert that to degrees, minutes, seconds. That becomes 2 degrees, 22 minutes, 59.567 seconds. So for whole degrees, minutes, and whole seconds, we'll round that up to 23. So this becomes 2 degrees, 23 minutes.